Hey everyone, and welcome back to the channel. Today we're diving deep into a topic that might surprise some of you. When you think about artificial intelligence, what programming languages come to mind? I bet Python is at the top of your list, right? And for good reason, it's fantastic. But what if I told you that one of the oldest, most foundational languages is secretly a powerhouse in the world of AI? That's right. We're talking about C. Now, you might be thinking, C, isn't that for operating systems and embedded devices? And you're not wrong, but that's exactly where its strength lies. In the fast-paced, high-stakes world of AI, especially in real-time applications, every nanosecond counts. And this is where C's legendary efficiency comes into play. Imagine a self-driving car. It needs to process a massive amount of sensor data, from cameras, LiDAR, radar, and make split-second decisions. Is that a pedestrian? A stop sign? Another car cutting in? There is absolutely no room for lag or delay. A sluggish response could be the difference between a safe maneuver and a serious accident. Python, for all its ease of use, has an overhead. It's an interpreted language, which means it's a step removed from the machine's native language. C, on the other hand, is a compiled language. It gets translated directly into machine code that the processor can execute at lightning speed. This means minimal latency and maximum performance, which is non-negotiable for real-time AI systems where immediate feedback is critical. Think about robotics, high-frequency trading algorithms, or even medical diagnostic tools that need to analyze data in real time. C provides the raw speed needed to make these applications not just possible, but reliable. So, C is fast. But there's more to it than just speed. The second major advantage C brings to the AI table is its ability to interact directly with hardware. This is a game changer. Modern AI isn't just about clever algorithms, it's also about specialized hardware like GPUs, graphics processing units, and TPUs, tensor processing units. These chips are designed specifically to handle the massive parallel computations required for training and running deep learning models. They can perform thousands of calculations simultaneously, which is what makes training a complex neural network feasible in days instead of years. Now, how do you get your AI model to fully leverage the power of these custom chips? You need a language that can speak to the hardware at a very low level, and that's C's home turf. It gives developers fine-grained control over memory management and hardware resources. This is why many of the core libraries that power AI frameworks, like TensorFlow and PyTorch, have their performance-critical backends written in C or its close cousin, C++. When you're using Python to build a neural network with a few lines of code, what's happening under the hood? Your simple Python commands are calling these highly optimized, super-fast C routines that are directly manipulating the GPU, squeezing every last drop of performance out of the hardware. C acts as the bridge, the universal translator between high-level AI concepts and the raw silicon that does the heavy lifting. Without C, our high-level AI tools would be like a race car driver without a steering wheel, all potential, but no control. Let's move on to our third point: lightweight applications. In the world of software, lightweight is a beautiful word. It means small, efficient, and not bloated with unnecessary features. This is especially important in the growing field of edge AI. Edge AI is all about bringing artificial intelligence out of the cloud and onto small, resource-constrained devices. Think about your smartwatch tracking your health, a tiny drone navigating a warehouse, or a smart home security camera that can identify a package delivery. These devices don't have the luxury of powerful servers and unlimited memory. They often run on small microcontrollers with very limited processing power and RAM. Trying to run a heavy, full-fledged AI framework on these devices is simply not going to work. It would be too slow, too big, and would drain the battery in minutes. This is where C shines once again. C programs are known for their incredibly small footprint. Because you have direct control over memory, You can create extremely lean and efficient applications that are tailor-made for the device they run on. A developer can write an AI inference engine in C that uses only the necessary resources, resulting in a program that is fast, responsive, and sips power instead of guzzling it. This allows us to embed sophisticated AI capabilities into everyday objects, making our world smarter and more connected. C's lightweight nature is what's making the Internet of Things, or IoT, truly intelligent. Finally, let's talk about scalability and simplicity. Now, calling C simple might raise a few eyebrows, especially for those who have wrestled with pointers and manual memory management. And yes, C demands a disciplined programmer. But when we talk about simplicity in this context, we're talking about the language's core design. C has a relatively small set of keywords and features. It doesn't have the vast standard libraries or complex object-oriented structures you find in languages like Java or C++. This minimalist philosophy has a surprising benefit when it comes to building large, scalable AI solutions. A smaller, more fundamental language means there are fewer layers of abstraction between the programmer and the machine. This transparency allows developers to build systems that are not only high-performing, but also predictable. When you're building a massive AI system that will be deployed across thousands of servers or devices, predictability is key. You need to know exactly how it will behave under stress. C's straightforward nature makes it easier to reason about performance and resource usage. Furthermore, because C is so foundational, it's incredibly portable. Code written in C can be compiled to run on almost any platform, from a tiny microcontroller to a massive supercomputer. This portability is crucial for AI companies that want their solutions to run everywhere. They can write their core AI logic once in C and then deploy it across a diverse range of hardware, ensuring consistent performance and behavior. This scalability, born from simplicity and portability, makes C a solid and reliable foundation for building the AI systems of the future. So, to wrap it all up, while Python has rightly earned its place as the darling of the AI world for prototyping and research, the silent workhorse language of C is absolutely indispensable. Its unparalleled efficiency is crucial for real-time applications where every moment matters. Its ability to communicate directly with specialized hardware like GPUs unlocks the true power of modern AI. Its lightweight nature enables the exciting new frontier of edge AI on small, everyday devices, and its fundamental simplicity and portability provide the scalable and reliable foundation needed to build robust, industrial-strength AI solutions. C isn't just a relic of the past, it's the bedrock upon which much of our AI-powered future is being built. It's the engine under the hood, quietly and efficiently making it all possible. What are your thoughts? Have you ever used C for an AI project? Let me know down in the comments. I'd love to hear about your experiences. Thanks so much for watching today. If you found this video interesting, please give it a thumbs up and consider subscribing for more deep dives into the tech that shapes our world. We'll see you in the next one.